everyone. My name is Chris, and I am speaking to you today from the Finlayson Field Center. The Field Centers are a place where students usually come to visit us for a field trip to learn more about things that they are learning about in school. We go outdoors and we explore in the different habitats that are here. Today, our lesson is going to be virtual, and we are going to talk about soils, which I understand you have been studying about at school. We could not survive on our planet without soil. Consider how you use soil every day. You walk on it. The air you breathe is connected to the soil. And think of how that can be. What gives us oxygen? Well, of course we know it's plants, but what do plants grow in? The soil. The clothes that you are wearing, how are they connected with the soil? Think of cloths like cotton or wool. Where do they come from? And how are they connected to the soil? And of course, the food that we eat. Everything in your lunch or your dinner or breakfast, the foods that we eat in some way are connected to the soil. Soils are made of really 4 key ingredients, or what we call components. The first component of soil is minerals. This rock is a mineral. Minerals can be large, huge boulders and can occur underneath the soil in the form of what we call bedrock. Forces in nature break these large minerals into smaller and smaller pieces over time. These smaller pieces, or what we call particles, are given names. So particles that are this size, you see here, we would typically call rocks, but ones that are this size we call gravel. The next size down, well, these are pebbles. Next, as those pebbles break down into smaller and smaller pieces, these pieces are called sand. Smaller than sand are fine-grained particles called silt. And as those particles of silt break down into even smaller and finer pieces, well, those are given the name of clay. This is the same clay that we use to make things with. So you've probably used it for modeling and making different objects with. Of course, there's a key component missing from this clay. You can see it's very dry and dusty. So I know you know what's missing from that. Now, 2 other important parts of soil that make soil healthy, and without it, soil would not be healthy. We need air and we need water. This is a picture of healthy soil. So you can see there are different size particles, and in between the particles there are spaces where there is air, and that allows water to move through as well. This is an example of an unhealthy soil. This is compacted soil. So something happened on the surface of the soil to squish the particles down and squish the air and water out of the soil. So you see, healthy and soil that has been compacted. This is what it might look like underneath our roads where cars drive. So underneath the pavement, of course, there is soil, but it would have been compacted because of the heavy objects that walk on them. Here at Finlayson, we have walking trails through the forest. That's where our feet go. Mostly we stay on the walking trails, and that is because wherever we walk, our feet will compact the soil, which can damage the soil. Where do you think plants will grow better? In compacted soil or soil that provides them with air and water? Lastly, we have organic material. And I'm certain that you are aware of what organic material is. Here's some organic material that I collected from the forest just this morning. Organic material is dead plants and animals on the surface of the soil. So we have things like leaves, we have sticks and branches There could also be living things within the soil as well, such as living creatures, perhaps worms and snails, all sorts of different things. Those living creatures eat this organic material and turn it into a very good, rich soil full of nutrition, full of vitamins that is found on the surface of the soil. This soil is called humus, not hummus. It is humus. You can see it's very dark, kind of crumbly, looks a little bit like chocolate cake crumbs. That's how you know a good, healthy humus soil. So remember, it is pronounced humus. H-U-M-U-S. Here at the field centers, we collect compost. And we put that compost, like our apple cores and banana peels, our carrot skins when we grate our carrots, we put those into a bin called a vermicomposter. A vermicomposter is a composter with an important ingredient. A vermicomposter has worms in it. These worms that we have are called red wigglers. And I'll put a few of them here on the table. You might be able to see them. They're squirmy, they're small, but these worms turn the compost into very good soil that, remember, is called humus. So these little creatures eat our banana peels and so on. It may go in their mouth as banana peels, but it comes out the other end as good, rich soil, again, called humus. We use that soil then in the house plants we have here at Finlayson, or we take them home and put them in our garden as well. Now, let's do an experiment. For healthy soil, we know there must be air and water in it. However, the air and water must be allowed to move freely through the soil. Otherwise, it's not healthy. So we're going to do what we call a percolation test. Percolation means water being able to move through something. So we are going to do a test to see how long it takes water to move through 3 different kinds of soil material. In our first container, we have gravel. You remember the rocks that are this size. Beside that, we have a container containing sand. It is smaller than gravel, but the sand particles are smaller than this last one, which is clay. The particles of clay are very tiny. So, I would like you to hypothesize. Which one do you think the water is going to percolate through the fastest? Is it going to go fastest through the gravel, fastest through the sand, or fastest through the clay? Take a moment and consider that. All right, let's do our experiment. First, let's try the gravel. Remember, these are the particles that are the largest. Here we go. Watch what's coming out the bottom. That seems pretty fast, don't you think? Here's the sand. Perhaps not as quickly or as freely, but the sand is moving quite fast. And then we have the clay. Anything? Nothing. So, I think you would agree with me that the water went through the gravel the fastest. And why do you think that might be? Look at the size of the particles and the spaces in between for a clue. The sand went through second fastest. And again, why do you think that is? You may know what sand feels like. When you roll it between your fingers, it will feel like sugar or salt, different than the gravel. And then finally the clay, still nothing. The particles of clay are tiny. So remember, the holes that are in between the particles of clay are very tiny as well. It will take hours and hours, perhaps even days, for the water to go through the clay. So consider, if you were a plant, would you prefer to live in the gravel, in the sand, or the clay? If you are saying that you would really not like to live in any of these, well, I would agree with that as well. Now, there are some plants that really like a sandy soil. There are some plants that really prefer a denser clay soil. And there are plants that like a rocky soil material as well, but not pure sand, gravel, or clay. Healthy soil is usually a combination of these. And this is just minerals. Remember, we also need that organic material. Without this organic material and the worms, we do not have humus. And without the humus, we do not have a healthy soil. A healthy soil is a combination of each of these things. Now, we have more things to explore, but let's take our explorations out.